Okay. I'd like to talk about three things today. The first thing is just try to wrap up about operator overloading, which is very interesting. Remember, I had this like a syntax error when I try to overload a Boolean operator with an integer. And then I was actually, at that moment, I didn't know what's going on. I thought I cannot overload a Boolean operator with another type. And then I realized that I actually, because I have a two, I will show you an example of what mistake I made. But it turned out you can actually overload an operator, even as a Boolean operator, like a equal or whatever operator. So essentially, you can overload any operator with anything. And it's just you have to be aware of a few rules. So that's one thing I try to wrap up operator overloading. The second things I would like to talk about is about it's related to the makefile, but it's more to the concept of separate compilation, meaning that what does that mean? You use the makefile, you just type make, everything magically happen. But internally, when I interact with some of you, actually I realize I probably need to spend some time to explain what is the separate compilation, which is actually happening inside the makefile, how you actually make things work. And the other thing which I will talk about today is actually about the difference between call by reference and call by value, which we actually touch on this issue. I kind of mentioned the concept here and there, but I feel it's still good to have really look into a good example for us to really just clear our mind about what do we mean by call by reference in C++ versus how do we do call by value in either C or C++, versus how do we do call by reference, or in this I actually call by pointer or call by address in the C style, but you can actually use it in C++. So it's a bit of confusing between C and C++, but I hope to provide, I actually upload this file. So in the future, if you have something unclear about this concept, you can just basically play around with example. So you probably know that my instructional style is basically totally based on program. Okay, so there is no theory in programming really. There is some theory you can learn in like 140, but as a programmer, it's really important. Every single concept you learn, you must have some programming example. That's why I'm so emphasized on that. So let's actually talk about the three things. First, let's talk about the mistake I made in the operator overloading, which is the operator equal. Let me actually just get rid of this. So I use the example person.cpp, person.h. So inside here, you can see that I have this two operator equal. Okay, so I'm overloading the equal operator with try to compare. So this was the original one, this line here. It was the original one, which is essentially I'm determining whether what's the functional meaning about comparing two person using equal. So that's the original one. Let me just remind you what is the usage of that operator. So you can look at the end. I believe it's at the end. What did I do? It's gone. Okay. Anyway, if I want to use this operator, I would say if person 1 is equal to person 2. If I do this, then essentially I'm actually comparing two person with the using this particular one. I mean, the reason I can do this is because they actually have the operand, which is a person, and also the return type is Boolean. So that's why if you do if person 1 is equal to person 2, then it's actually going to be matching that one. So it is actually going to match with this function, Boolean operator equal like this. Okay, it will match this one. Okay, so now let's actually look at the second one. Let me actually clean this up a little bit. But remember last time, if I do this, and if I actually put an M sign here, if I do an M sign here, then if I actually compile, okay, I'm going to, this was an error message I got. So I didn't actually read this very carefully, but it says that function that differs only in their return type cannot be overloaded. Only differ in the return type. So what is the return type here? The return type, did I kill it already? Okay, the return type difference between these two is Boolean and integer, and other than return type, everything is the same, right? Everything is the same. So what I did is actually a bit sneaky, I would say. I just get rid of this reference. You can see the difference between these two functions. So one is with M. So what is M? That's the second topic I'm going to talk about is reference. So this one is a person M, which is the reference of an object, versus this is the person without the reference. When I actually make this small changes, so I actually make this two function signature differ more than the return type. So not only the return type is different, but also the what do you call that? The parameter type is different because person and person M, they're different. One represent an object and the other represent a reference of an object. So therefore, when I did this changes, sorry, I should get rid of this as well. When I did this, then everything compiles successfully. Okay, so you can overload the operator. It was a Boolean. Now I successfully overloaded to be returning an integer. Let me actually show you what I did in my program. Person.cpp. So take a look at how I did the operator overloading. Look at this implementation. This was the original one. The function prototype is matching an end. And this one is a new one that overloaded with an integer. So essentially, I actually do a two equal sign. I mean, whether it makes sense to return an integer for operator, this totally programmer's choice. I could return something totally different, which maybe is a pointer or a reference to another type of object. That's okay. But you can see that over here, I just return integer 5 according to whatever that signature. You can return, say, the difference about this two-person's salary, for example. You can actually take salary 1 minus salary 2, or you can say what's their grade between those two as represent as an integer. Okay, so that's essentially you can do. But the thing is that the lesson I learned myself is that if you want to overload multiple one on the same operator, the difference must go beyond the return type. You must have some other difference in the argument of the overloading operator as well. Okay, so that's the first one that kind of wrap up the operator overloading. So that will lead me to the the second topic I would like to talk about, which is the difference between value reference and the pointer. This has been bothering a lot of us for a long time. So let me try to use this example. So I actually upload the example to GitHub. This is GitHub, still in CPP01. And I actually have this new file called objectreference.cpp. Yeah, it's objectreference.cpp. I just uploaded earlier today. So I'm actually going to use this, just let you see the program. Okay, so this is a very simple program. I define I would call it a dummy class. I call this class item underscore ecs36b. And I essentially put everything in the public. All right, so that's a trick. In fact, in the engineering, when I try to write a lot of program, sometimes just for convenience, I put everything in the public, so I don't have to worry about like the first question I asked you in the midterm, the difference between private and public. Okay, so you can see that I have two items, which is one is a string, one is a quantity. Okay, so now I'm actually going to write a function. So this function is a function. It's not a member function. Okay, it's not declared there. I mean, I can do that because now everything in the public. So let me actually show you the first two functions. The first function is called set quantity by value. And the second function, this is the first function, set quantity by value. And the second function is, I call it set quantity by reference. Okay, so I want you to actually focus on these two functions. And please tell me what's the difference between these two functions besides the names are different. Besides the function name, what else is different between these two functions? Yes. Uh-huh. Right. So the only difference, thank you very much. What's your name? Alex. Okay, thank you, Alex. So the only difference is this character. So that's what we're looking at. The first one is really you try to pass an object as a value into the function called set quantity by value. And the second function is put the M sign. I don't like that. Okay, this should be okay, right? Did I do something wrong? Okay, so the second function, I actually add the M sign, and this is essentially a object reference. So there's two types of difference we need to be worried about. The first one is, what does that mean to have a M sign in the operation of your program? What does that imply? The second one is, well, if you actually have this difference, just one character from the user perspective, means that I actually want to write a code to call this two function, the usage difference between two. So first I want to talk about the internally from the programming language implementation point of view, what's the difference between these two? The main difference is that when I actually make a call to the first function, before I call this function, I actually need to make a copy. Need to make a copy of item. So essentially, whatever you pass into this function, set quantity by value, because you didn't have that M sign, I need to find another memory location and copy the value of the original one you try to call it, and copy over there, and then call this function. That's actually, sometimes we just say, if you call by value, anything, by the way, in the C++, whenever we say call by value, it implies you actually make a copy, and then you call the function. But the second one is what I call set quantity by reference. That means I don't want to make a copy. What I did is I put the reference. So essentially, you're passing the address of the original memory cell which contained that object. So essentially, I pass the original copy without making another duplicate, and then have that copy go into that. So that's the difference. So essentially, the first one is less efficient than the first one, than the second one, because you avoid a copying. By the way, copying in programming language implementation, it sometimes could dramatically degrade your performance. So, okay, so now you know functionally that's the difference. One make a copy, one not make a copy. But the second issue is probably more important from the usage perspective about this difference. And when you have this two, what does that mean? So let me actually tell you the program I wrote. So you can see that here, I create an object called myItem. Okay, I create an object called myItem. By the way, have you noticed I didn't have any constructor? The program doesn't have any constructor because in C++, there is something we call implicit constructor. You actually saw me using the term explicit. That means you try to say, hey, the constructor has to be explicitly defined. But in C++, if you don't say that, that means implicitly is going to do some kind of dummy constructor for this object, okay? So I'm actually using that implicit constructor in this case. All right, so let's actually see what I do, what kind of things I'm doing. So essentially, I create an object called myItem, and then I actually set the myItem.quantity to be 0. Okay, so because it's everything is in public, so I can use that dot operator to basically set the value. Okay, here is the first thing I'm going to do. I'm actually going to call the first function set quantity by value, and it's myItem and then 10. Okay, I set the myItem's quantity to be 10. And the second function, I set the quantity of reference to myItem to 1000. Okay, I set 10 and then I use a reference. So now you can see that every time I set the quantity, I actually print the value. I print the value. By the way, have you noticed? Now I first time introduce a new way of printing than printf, right? I'm using stdcout. Okay, so this is a C++ way of doing printf. Let's try to compare. I mean, I believe in general, I like cout better than printf because cout is better organized and it's more readable. I don't have to worry about the format string, for example. And so it's your choice. Now you gradually see some example. So let me actually tell you that what is a stdcout. So it uses this string format. So that's why if you want to use cout, you have to add this line called IO string, because this is C++ way of handling IO. Is actually looks like a string of character. You send it to the output. So let's actually use this example. So stdcout. And then I said, okay, you put the string, the original quantity is, and then you say myItem quantity, and then at the end is a standard n line. This is like a \n. Okay, it's like a \n. I mean, if you don't like this, you can actually do either this way or this way. These two are the equivalent. I can actually do this as well. If you really like a \n. So these two lines, they're the same. One is using std n line. The other one is just still using string. So you can see that this is actually a better way to organize. Well, I shouldn't say better, depending on your taste. But this is a different way of organizing the information to send it all the way to cout. I mean, you can do cin as well. So cout is like a printf. Cin is like a scanf. Okay, so that's a C++ way of doing this. Just leave it here so you know the difference. Okay, so now I want you to actually think about, look at this program just from here up to here. So I have a 3 quantity that's going to print it out. So there are 3 numbers. They're all referred to my item.quantity. In fact, the core variable I like to print is the my item dot quantity. I want you to say what should be the first value, the first my item dot quantity, and what should be the second one, what should be the third one. And the difference is that I set it to be 10, I set it to be 1,000. What's your expectation? I want to give you maybe 10 seconds for you to understand this piece of code. 10 seconds. Look at this piece of code. Okay, what should be the first line? What should be the first print C out? What should be the value that's printing here? 0, right? The first one should be 0. We're expecting a 0. Let me actually just put it here. I'm expecting to be a 0. Okay, how about the second line here? What should be the number? Any other option? 0, right? Okay, this is actually between 0 and 10. Okay, we have 2 answers. I mean, the answer is 0, but we need to know why is 0. That's why is call by value is important. Okay, that's probably the most lesson I want you to learn. Why at this stage it will be 0, not 10. Okay, so essentially when I set the value to be my item 10, I use quantity by value. What does this mean? Will I make a copy? I'm going to make a copy, right? It's called by value, so I'm going to make a copy. So essentially, okay, I'm going to use this one, whatever's paper. So the quantity was a 0, right? That's something I want to do. And I'm actually going to call set quantity by value. So what does that mean? I'm going to make a copy. Means that I'm going to find another piece of memory and I'm going to copy the value. Let me use a different color pen. I like they actually give me this pen. That's perfect. Okay. So now I actually have 2 copies of the same value quantity 0. And remember, blue is what? Blue is the my item, right? I got it from the original object, my item. But now I have a different one. And this one is actually going to pass into this function, which is underscore item. So essentially what I'm saying is that this blue is from my item. And this 0 is from underscore item. Okay, if you always remember this too, I have 2 copies. One is my item, one is item. Okay, so now when I try to execute this function, set quantity by value, what did I do? What's the underscore quantity was 10, right? And then when I do underscore item dot quantity is equal to quantity, I'm actually change that value to be 10. But which copy I actually change to the 10? This copy, because this is underscore item within that function. So then I actually make a change to 10. So now if you look at your memory, if you can see your memory, this is what you got. In your memory, okay, the other thing I want to tell you, when you do a call by value, when you actually return the function, it doesn't copy back to this object, okay? So just make a copy when you call it, when you entrance the function, but not copy it back. So essentially, when I actually get back from this function, I'm having this. Okay, so this is still 0, and this is so, which means that I copy it, doesn't work. So that's why when I have it here, over here, is actually when I print my item.quantity is still looking for this one, my item.quantity. It didn't look for this one. So that's the difference between call by value and call by reference. Make a copy, and you make any changes, the outside of that function set quantity by value. Anybody outside of the function, you don't see any changes. Okay, that's call by value. All right. Okay, you got it? Or any question about this? I just want to make sure everybody here understand that why set quantity by value over here, the output is actually going to be 0. Yes.
Sorry, 2 questions. So is this only, does this only happen in C and C++?
Yes, but I'm saying that any language want to make the difference between call by value and call by reference, they're going to have the same result. Any language that want to implement this concept, I believe you encounter the same situation in Java as well when you do this. Okay, so it's really, I mean, get back to the principle is that, to me, the best answer to this question is whether you make a copy. Whether you make a copy when you actually access a function. If you don't make a copy, then yes, that changes will be visible from outside. If you make a copy, everything is only, any changes will be only be seen in that particular function that you actually make a call by value into, okay? So just remember, if you don't remember this, remember orange versus blue, okay? Is this? Wait a minute. Orange versus blue, that remind me some MLB game yesterday. Yeah, somebody lose. The orange lose, I think. Okay, I'm talking about Oreo. All right. So anyway, let's actually look at the other one. Look at call by reference. Now you might guess, well, okay, look at this 2 line. What should be the output of this one? So it shouldn't be surprise to you that this is going to be 1,000. This time it will be 1,000. And why is that? Let's use this paper again. Okay, so when I call it, I didn't make a copy. Okay, so when I go into the function, my item, because it's called by reference, is actually going to be underscore item. They're actually referring to the same copy. So that's called by reference. So I'm actually calling it, I'm just passing the label in here, and it still do this. So when you actually try to modify like this, you try to do item.quantity is equal to quantity, which is 1,000. You actually is going to change this function here, 1, 0, 0, 0. Okay, I'm sorry, the 0 is different size, but it's 1,000. Okay, so I actually changed this copy. So now you can see that from outside, you can see it's 1,000. Okay, so this hopefully, let's try to run this program to just verify. Okay, you can see that now the results printing 4 lines. Originally is 0. The call by value is 0, and the call by reference is 1,000. Okay, so we actually have the 3 line verified. I mean, this is probably the most important difference I want you to learn. The difference is why you add the and sign. It suddenly make any difference. the real difference is whether you make a copy or not when you call it, and whether from the outside you can see the change to that variable that you put the reference. So that's a two major difference with that one M sign over there. Okay, so so now I'm going to move on to another topic, which is call by, I call it call by pointer, but when I learned C, I call it call by reference, by the way. But I'm actually going to say call by address. Let's actually see what's the way to do it. So I have the third function. This function, now we look at this. I currently call it call by set quantity by pointer. Okay, but it's really reference. You will see what I meant. I'll just look at this function. So now you see the first argument. Instead of saying that item ecs36b and or without the and, I now say item underscore ecs36b star. Okay, for those of you actually who either came to my office hour or actually listened to watch the tape, the way I always interpret the star, because star is sometimes confusing. You sometimes have a 1 star, you have a 2 star, you have a 3 star. In fact, you can have 200 star over there. It's just reference pointer, pointer, pointer. Okay, you can do anything. The way to interpret is always put all the star together with the type before the first star. Regardless how many stars you have, just always cast. Because the way to read it is that this set of string under this 2 parentheses I put it there represent a data type. That data type, if you have this example, is basically the data type is a pointer or an address. Whenever you have a 1 star, it already became an address. And then essentially, when you have an address, then this pointer to a class called item ecs36b. So that parenthesis basically, if I want to read it, is saying that this is a data type of a pointer, and this pointer is it's a ecs36b pointer. I mean, by the way, if you put 2 star, I can actually interpret this way. Okay, the whole thing is a pointer for the first star, but what is the point data type of this pointer pointing to is actually another pointer to so it's an indirect pointer to that. Okay, so that's the way to interpret the pointer. So then let's actually go back to original code. The original code looks like this. Okay, so essentially now when I call, the first argument is a pointer. And the pointer is pointing to a item ecs36b object. Okay, so this is a pointer representation of a reference. It's a pointer. So if there's a pointer inside here, now instead of saying item.quantity, you can see that I call it item PTR. So I use the pointer format underscore item pointer to the quantity. By the way, just make sure that this is really flexible. I can actually write the code looks like this. This is no problem at all. I can actually dereference, and then I put the dot operator. These two are syntactically, semantically equivalent. All right, so you can see that if I have a pointer, I can actually just use the pointer notation into that particular member, or I can actually reference a pointer, which is you add a star at the beginning. So sometimes pointer is really confusing because if you put a star before and after the parameter name, it means totally different. Okay, so before you put a star in front, that means this is a dereference. If you put a star after a type, that means it is a pointer type. Okay, I just want to let you know that syntactically. So you can actually dereference and then put the dot operation. These two are equivalent. I will leave the code here for you to actually know what's going on. Okay, so I'm actually saying, okay, you pass me a pointer value, and then I do this. Okay. So the thing is that, let me look at the code. Now look at the code. The third one is that now you can see I said call set quantity by pointer and my item to be 3,000. Okay, I'm just changing that value to be 3,000. Not so surprised, the last one is going to be effective, 3,000. Let's try to run the program again. You can see that the third one was 3,000 when you run the program. Okay, why is that? Okay, let's actually parse this a little bit. So when I call this set quantity by pointer, what's my first argument? The first argument need to be a pointer because it was declared as a pointer in the function signature. And therefore, how do I get from the object to the address of the pointer? I add and sign in front. So this is another confusing. You have to write this kind of program a lot to actually really feel comfortable about the position of the and sign. The and sign, put it at the end of the a class name, it is a reference. But put it in front of the object is actually the address. So you look at the way I do it is if I actually put a star at the end of something, that something must be a data type, either a class or a basic type like an int. But star and n, if you put it in front of something, that in front of something must be an object or the variable. So let's actually try to compare this two a little bit. Sorry. If you look at this way, you see that if I put an n here, it must be after the green, which is some kind of class or some kind of data type. And if I put a star after that, it must be some kind of data type as well. Okay, so if you put star or n, that's actually just a type. You actually declare it's a reference type or it's a pointer type. But if you put something in front, for example, over here, I put a star in front, then this part must be a variable. It cannot be a type. You won't see a type. You cannot have something looks like this. In this case, you cannot have something like a star item ecs36b when item underscore ecs36b is a class or is a type. You cannot have that. Nor you can have this one. You cannot have item, m sign item ecs36b. Okay, because if you put those star and n in front of something, it must be represent either is a dereference or is an address. Okay, there's two. So just to look at the sensitive to the position of this two very strange, very unique character is important. Yes, please. Well, it is actually different. If I put a star and an n from at the beginning, they means different thing. Because this means this, okay, so let's actually use a real example. If I have item underscore PTR, right? So if I do item PTR versus m item PTR, by the way, it's an excellent question. What's the difference between these two? Star, assuming item PTR is something, right? Some argument or some variable. What's the difference between star item PTR and n? Yes.
They're like opposites, or and item PTR is an address.
Uh-huh.
If item PTR is an address.
Right. I think you understand. That's great. Let's actually use an example. Assuming I have a content. Okay, I have a content, and this content, pick a number for me. 25. 25. Okay, I'm actually have some value. That's actually 25. But now I'm actually going to talk about the concept of address. The address, assuming, give me a number.
21.
21. Okay, so the address is 21. And at the address 21, I'm actually putting the value 25. All right, so that's the 25 over here. All right, so now I'm actually going to say what is what I call item underscore PTR. So item score PTR is what? Is a pointer to an object, right? Item score PTR, where is that? Yeah, it's actually, you can see it, declare item underscore PTR is item underscore ecs36b star. That means it's a pointer type. So it's a pointer type, it must contain an address. Now let's see what address I have. I actually have at 21. So essentially, this address, the content of this item PTR is at 21. Okay, however, this must be somewhere. By the way, this is somewhere in your memory at 21, but where do I put this? Can you give me another address? 7. Just let you know, you guys will have been failed, okay? Both this address will cause segmentation fault. But anyway, I will remember the first virtual page is never be used, okay? So okay, that's okay. I'm just kidding. Thank you for your answer. Okay, so the address is at 7. So just let you know that the mailbox 7 is actually itself is an address. It put at 21. And where at 21, you put the value 25. Okay, so it's very, this is a 7, mailbox 7. This is mailbox 21. This one is contain an address, but this one is contain the value.
So a pointer is basically a memory location that holds another memory location.
Yes.
While the end is called.
Yes.
Well, the end is basically a memory that holds the value.
Right. Exactly. I mean, I like this kind of example because it actually gives you a real idea of what the pointer is. Yes.
So where do you store in star items that PTR? Where do you store in and
that's what I'm going to get into. Thank you. Excellent question. Okay. So now we have this, right? So now I want to interpret this to star item PTR. What should be star item underscore PTR? I know this is item PTR, right? What should be the star item PTR? This is called dereference, right? This is called dereference. This is basically say, whenever I say a star, I said, what's the content of this one? And what's the content of this one? At 21. So it's 21. So if I do star item PTR, this is actually going to be 21. But what should be the M item PTR? M item PTR is the address of this item PTR. What should be this? 7. Okay, so the reason I want to get it, this is a little bit tricky if you first time heard about this, about C pointer. It's a concept in C or C++. It's about the location, memory location, and the content you actually put into that memory location. So let me actually make it even more complicated. What is star item PTR? You know what? I make a mistake. I made the, wait a minute. I'm actually confusing myself a little bit by looking at a different piece of paper. Let me actually say that. Okay, what is, sorry. I know what I'm missing. Sorry about that. The other one is item PTR. Sorry, there are 4 lines. The item PTR is actually I'm so sorry. Okay. The item is this one is actually going to be 25. Okay. I actually saw some of your faces. You have this 3-line created when you saw my answer. That's totally represent that you're so smart. You actually immediately realized my mistake. Okay, so now we have this 3. Okay, now this 2 are okay. This 2 are okay. But the first thing is item PTR. When I say something called item PTR, I'm really looking at the content about this. So I'm actually just printing the content. So what is the content over here is 21. Okay, so if I say just item PTR is actually the content, it's just like I say integer I. What is I? I is essentially the content. So without star or without n, it's just whatever being stored in this particular memory location. And then if I say and item PTR, I'm actually looking at the address of this particular location. So that's why it's S7. That's actually the address. That's fine. But the interesting thing is the middle is dereference. So dereference means that I'm actually taking a look at the content, which is 21. When I'm looking, I treat this itself as a reference. So that's why I'm actually going to use this 21 as the address. And then I actually go to say, where is 21? Address is here. And what's the content is 25. So that's why star item PTR is 25. Okay, so understand. I'm sorry. So sorry if I confused you like 2 minutes ago. But you understand this 2 picture, but looking at the 3 notation: item PTR, star item PTR, and n item PTR. Okay, it's kind of complicated. Okay, I hope you. I hope I'm not confusing you more about pointer, but hopefully you will learn eventually.